Welcome to qnawire.
So we're going to apply Bernoulli's equation and the equation of continuity. And before we start doing these calculations, we need to we're going to say 0.1. So we need subscript 1. This is going to be the surface of the water in the tank. And then we can say 0.2. This would essentially be the stream of water emerging from the tank. So given this, we can then apply Bernoulli's equation, P sub 1 plus rho g y sub 1 plus 1/2 rho v sub 1 squared. This will equal P sub 2 plus rho g y sub 2 plus 1/2 rho v sub 2 squared. And so we can then say we know that from the equation of continuity that v sub 1 is equaling pi times d sub 2 squared divided by pi times d sub 1 squared. Of course, the pi's are going to cancel out, and this would be multiplied by v sub 2. We know that d sub 2 is equaling 0.0200 meters, and we know that d sub 1 is equaling 2.00 meters. So essentially, because of this, v sub 1 is going to be much less than v sub 2, and so we can neglect this term here. So this term can be set to 0. And so given this, we can say that v sub 2 would be equaling the square root of 2 times p naught divided by rho, and this would be plus 2gh. We know that h is going to be equal to y sub 1 minus y sub 2, and p naught would be equaling the difference in pressures, and this is equaling 5, we can say 5,000 pascals. We know that initially h is going to be equal to h initial, and this will be equal to 0.800 meters. And this is when, rather after this initial height, when the tank is drained, of course, we can say that h is equaling 0 meters. So we can then substitute and say v sub 2 is equaling the square root of 2 times 5,000 pascals divided by the density, 1,000 kilograms per cubic meter. And then this would be plus 2 times 9.8 meters per second squared, multiplied by, again, 0.800 meters. Extend the square root. And this is equaling 5.07 meters per second. If the tank was open to air, this means that here, if tank is open to air, we can then say that P naught is equaling 0 pascals. And so V sub 2 would simply be only equal to 2gh, or it could, again, we could write it two times 9.8 times 0.8. And this V sub 2 would then be equaling 3.96 meters per second. So essentially, the ratio, we can say, we can say V sub 2 prime. So V sub 2 divided by V sub 2 prime, this would be equaling 1.28. This would be our answer for part A. For part B, now, we know that v sub 1 is equaling the negative derivative of the height with respect to time, and this would be equal to a sub 2 divided by a sub 1 multiplied by v sub 2. And so this is going to be equal to d sub 2 divided by d sub 1 quantity squared multiplied by the square root of 2 times p naught divided by rho, the density, plus 2gh. And we can set this would be equaling d sub 2 divided by d sub 1 quantity squared multiplied by 2, the radical 2g, multiplied by radical p initial, or p naught, divided by g times rho plus h. Now, separating the variables gives that here, we can write it here, dh over the square root of, rather, my apologies, p initial divided by g times rho plus h. This would essentially be equal to negative, and then we can say d, we can write it a little bit smaller, negative d sub 2 divided by d sub 1 quantity squared multiplied by 2g times dt. Let's reduce the square root. So essentially, we can then essentially integrate. So we can, let's get a new workbook for part B. We can integrate from the initial height to 0, and then this would be dh prime divided by the square root of p initial divided by g times rho plus h prime. This would be equaling negative d sub 2 divided by d sub 1 quantity squared multiplied by radical 2g multiplied by the integral from 0 to t of dt prime. And to do the left-hand side integral here, we need to apply u substitution. And so we can say that u is going to be equaling p initial divided by g times rho. This is the only way to solve this integral, plus h prime. Now you can do integration by parts, but u substitution is much easier. And so this essentially makes that du is equaling dh prime. And so the integral then becomes much easier, and we would get an integral on the left-hand side only, the integral of du over u to the 1/2 power, or the radical u. This is easily integrated, and so we can then say that finally, for part B, we can write it here. We have enough space. 2 times the square root of p initial divided by g times rho minus the square root of p initial divided by g times rho plus h initial, extend the square root, close parentheses, and this would be equal to negative, again, d sub 2 divided by d sub 1 quantity squared multiplied by t times radical 2g, or the square root of t of 2g. Now we're going to solve for time. So solving for part B, solving for time, this is going to be equaling d sub 1 divided by d sub 2 squared multiplied by radical 2 over g, and then this would be multiplied by the square root of p initial divided by g rho plus h initial minus the square root of p initial divided by g rho, close parentheses. We know that since P initial over G times rho. This is simply going to be equal to 5,000 pascals divided by 9.8 meters per second squared, multiplied by 1,000 kilograms per cubic meter. This would be equaling 0.5102 meters. Let's get another workbook. So for part B, keep in mind this number because now we're just going to plug it in. And we can say that T is equaling 2 divided by 0.0200 quantity squared multiplied by the square root of 2 divided by 9.8 meters per second squared. And this would be multiplied by the square root of 0.5102 meters plus 0.800 meters minus the square root of 0.5102 meters. And we find that T is equaling 1.944 times 10 to the third seconds. And if you wanted to divide by 60, we have approximately 32.4 minutes. This would be when the initial pressure is looks like a rho. The initial pressure is equaling 5,000 pascals. Now, when the initial pressure is now equaling to 0 pascals, we can solve for T once again. So T is going to be equaling, again, 2 divided by 0.0200 quantity squared multiplied by the square root of 2 divided by 9.8 meters per second squared. This is going to be multiplied by the square root of 0.800 meters. And this is equaling, T would then be equaling 4.04 times 10 to the third seconds. And if you want to divide by 60, approximately 67.3 minutes. And here we're going to call this T prime, just so that we can say then the ratio T prime divided by T would be equaling approximately 2.08. So this would be our final ratio for part B. That is the end of the solution. Thank you for watching.